Hello, hello, hello. Good morning. We are live. We are starting a new unit today. Statistics. Well, today I am Strange. Mr. Strange. Refer to me as Mr. Strange. Anyways, we're starting a new unit, statistics. Learning intention states that we are learning to use functions to model relationship between quantities. That's literally all we're going to be doing for this week. The first thing we're going to be focusing on is constructing and using scatter plots to investigate relationships, including identifying associations, clusters, and outliers in the data, however you say it. Your business, not mine. Anyways, simply put, whenever we're talking about scatter plots, you have your X and your Y axes, okay? Scatter plots is literally just dots. They are scattered. They are scattered. They are scattered. Scattered. All right, it's literally just scatter plots. That's what that is. Dots all around. Period, big dot, no space. All right, so we're going to look at what it means to have a scatter plot correlation. We're going to talk about outliers. And then later on in the lesson, we will talk about lines of best fit. Before we do that, I want you to look at this question. Zoom recording. Now, to talk about scatter plots. All right, so to introduce what the scatter plots are, we're going to look at this question. It says, suppose we are to look at the number of years worked compared to the annual salaries for employees of a certain company, and we got the following results. So on the left, it tells the number of years someone has worked, or each person has worked, and then it tells on the right how much they are making. Obviously, this doesn't show anything about if you increase in years, you start making more. Actually, you probably do, because the person that's working 70 years is making a lot more money than the person that's only been working for 1 or 2 years. So whenever we're talking about scatter plots, we want to take data from a table, all right? And then we're going to show you how we put this on a graph. So before we continue, we want to look at if there's a relationship between the two quantities. The years worked and the annual salary, we call those quantities. We call those quantities, all right? Years worked and the annual salary. So if we're talking about scatter plot, we're trying to figure out the relationship between two quantities. Not one, but two quantities. If you were supposed to describe the relationship between both of these quantities, how would you describe the relationship? All right, so if we're talking about the relationship between the two quantities, all we got to really look at and say is for every year you work, you make more money. Period, big dot, no space.
I was gonna say that, but I want to let other people get it.
Uh-huh. So the first year you work, you get 28,000. Then the 7th year you work, you're at 76,000. We could say that the more you work, or the more years you've worked, you will increase in salary. Now, if we're supposed to put this on a scatter plot, this is where we get into the meat of the matter. So we take the information on the table and we put it on our graph. Often it is helpful to represent the information in multiple ways to see how the whole picture comes along. One of these representations is called a scatter plot. This graph right here is a scatter plot where the data is plotted as points on a graph. The y-axis, if we look at the y-axis, it shows the annual salary. If we look at the x-axis, it shows the years worked. So all we literally do, figuratively and all the leaves, I don't know if it's figuratively, we take the information on the table and put it on the graph. So where it says 1 year worked is 28,000. So I put 1 year and I match it up with 28,000. Remember, you put the X value first and then you put the Y value. Period, big dot, no space. Any questions about that? For people online, if you have any questions, go ahead and put it in the comment section. I will see them and I will respond. Now, whenever we're looking at scatter plots, we want to ask ourselves the question, if this scatter plot helps us to determine whether or not there's a relationship between the two quantities. All right, whenever we're plotting lines and all those different things, we use lines to determine if there is a slope, if there's a rate of change, or if there's a connection between the two quantities. And that's where we introduce the term correlation. This is something that we will need to know. Hey, friends, y'all need to know this stuff, okay? Correlation. One of the things we look for in a scatter plot is called correlation. Correlation refers to the patterns that we can see in a scatter plot. Resume. Correlation refers to the patterns that we can see in a scatter plot. So if there are patterns on there, we all can pick up on patterns. We could tell if something is red, 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 blue, 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 red, 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 blue, blue. We can pick up on patterns. All right, just like with friendships. One part of correlation is that we look for is whether it's positive or negative, just like with regular life. We could tell if something is positive or negative sometimes. Okay, so we look at the correlation and tell if it's positive or negative. Positive correlation exists when an increase in one variable corresponds with the increase of another variable. It creates an uphill pattern. So if the thing, I said thing, if the pattern is going up, that's positive. If the pattern is going down, that's negative. Negative tends to mean one of the variables is increasing while the other is decreasing. All right. Now, another part of correlation that we need to look at, it's called strength. Strength. Strong correlation exists when the points are tightly grouped together in a straight line. Bam. Strong correlation deals with when the points are tightly grouped together in a straight line. It becomes weaker when the points starts to scatter. The last thing to look at when it comes to strength is if the points are too spread out, all right, and there's no pattern to it, then there's no correlation. Points are too spread out and there's no patterns to it, then there is no correlation. Now let's look at some graphs that talk about exactly what I just said. This is the last thing for this part. All right. This would be a strong positive correlation because it's going uphill, but then the dots are also tight and they form a line. The second one would be a positive correlation because it's still going uphill, but it's weaker because the points are spread out. Do we see the difference? They're still both going uphill, so they're positive, but one is tighter than the next. Okay. Next one, these two, well, the one on the top, that one is negative, and it's fairly strong. They're not tight points, and they're not weak points. They're not spread out, but it's negative because it's going downhill. And then this one, there's no correlation. They got dots all over, man. Okay. Real quick. All right, thank you very much for tuning in. I will see you next time. Please check out the other videos, like, share, subscribe. Bye.